speaker is Jim Morgan. Jim has over 32 years of experience in the uranium enrichment industry, working both with the Department of Energy and NRC regulated facilities. He's got 17 years of centrifuge enrichment technology experience. He was the plant manager for enrichment operations at USAC's American Centrifuge Program until he retired in 2005. He's going to talk to us today about an operations perspective, culture of compliance. Jim.
Let me first, talking on compliance, I'd have shot the nun. Well, I'd set the stage for the difference between history perspective and that of a plant manager responsible to see that we provide a facility that's compliant, because as Ray mentioned, that incident had far-reaching effects to every facility that implements DOE security requirements and every facility that's responsible for safeguarding nuclear material. And for a long time, we've had one of our mantras in the nuclear industry is an accident anywhere is an accident everywhere. And you've seen that with what happened at Fukushima. And so what you see is the problems that were encountered at Fukushima have impacts on other countries' nuclear programs, and they significantly have an impact on the image of the public. And if you get to part of the root problems at Fukushima, everybody said, well, you can't stop a tsunami. And you cannot, but through safety analysis and routine reviews, the people at Fukushima, responsible for Fukushima, were aware that they were vulnerable in certain areas. And much like the incident that occurred at Y-12, you can go back to a lot of the design work, the safety work, the analysis, the programs you put in place. And whenever you have almost 100% when you have an incident, you've had a breakdown somewhere in either a program, a design, or something you've done to make your commitment for compliance. There's been a breakdown in that, and when Ray spoke, he spoke about 3 different steps that went through, that people had an opportunity to have done something that could have reduced the impact at Y-12. What I want to do in this discussion is a little bit take you through just a very simplified project flow diagram regarding the steps you go through in designing a facility. And realizing I'm doing this from the standpoint this morning of trying to highlight the efforts that's put into the design to identify and implement safety design and practices to ensure that your plant is operated safely. With that, I'm going to also go through a visual indication, display that we created when we received our license to run a lead cascade of equipment at Portsmouth. We were the first enrichment facility to receive a Part 70 license for the operation of a centrifuge facility, and we chose to operate just a confined number of centrifuge machines. I'm going to share a little bit about what we did as part of that licensing application, and then share with you a best practice that we developed and implemented again in order to ensure our compliance with the commitments we were making to the Nuclear Regulatory Commission. Then I'm going to talk briefly about a couple of the management measures that are utilized as part of your ongoing operation. And when I say walking the talk, we'll talk a little bit about the mindset that you want to train and create in your employees that are operating these facilities. Here is a very simplified project flow diagram going from a preconceptual, and lots of times that, in your terminology you'll learn, sometimes these are referred to as feasibility studies. where we look at the scope of what it is you'd like to do. I'd like to build an enrichment facility. I'd like to enrich up to 3 million SWU a year. I want to produce these assays, and you just basically, what's the scope of the facility and what is it you hope to accomplish? And designing the facility, Ray alluded to the technology. I was involved with the previous DOE centrifuge program, and I was with USEC centrifuge program for 5 years. So there's a lot of design and things that go into designing your machine, designing your cascade, designing your feed systems, your withdrawal systems, how you're going to do your sampling. The operational piece, what I want to talk a little bit about today is how from the very beginning you start to identify what are the regulatory compliance with which I must comply. And we look at what are the physical security, and that's kind of from 2 aspects. One, I'm protecting classified information. And with the centrifuge, there's still information in the centrifuge program that is SRD, secret restricted data, requires a Q clearance for access. Also, there's the physical security of, I don't want uncleared people in my facility, which is exactly what happened when the nun cut her way through the fence. Then there's the national safeguard perspective. I have to be able to account for all of my nuclear material. There's regulation safety, there's criticality safety. Obviously I can't afford a criticality accident, but if I'm getting a license, I'm getting a license to possess a certain amount of material. I'm getting a license to enrich that material to a certain level. You make that commitment. You're enriching it to a level. 2 reasons. One is the proliferation of nuclear enrichment piece, and the other is to ensure that you have a stout nuclear criticality safety diagram or program. I'm sorry. Then you get in your system requirements. You take these requirements and you turn them into, these are typical design requirements and system requirements. You create your flow diagrams of how your process will work. And you incorporate into those diagrams not only what's necessary to produce the end product that you want to produce in an enrichment facility between 3.5% and 5% material, because that's typically what's utilized by today's reactors. But you also begin to work into your design, how are you going to meet these regulatory requirements. And you do a lot of analysis. You do assessments and analysis. An integrated safety analysis, and I'll speak to here in a minute. That's an analysis where you analyze your process for the various accidents or things that could go wrong associated with your design from a safety assessment. Vulnerability analysis predominantly is where am I vulnerable for theft, misuse of facility, that somebody could steal the material, is a mechanism by which somebody can utilize my design and produce material of higher assay than what I have in my license, and how do I ensure that does not happen at my facility. Process hazards analysis at our facility primarily involved the chemicals with which we used to work, and nuclear criticality safety. How do I ensure that I do not have an inadvertent nuclear criticality accident at my site? How much of that can I do through design by ensuring that I design piping and containers that always have safe geometries and of certain diameters and certain measurements? And at what point do I have to apply administrative controls? At what point do I have to apply some specialized instrument to ensure that, for example, the air stays below a certain dew point? Things of that you start to build in, and notice we're building these in very early while we're doing our conceptual design. You work through your detailed designs, your drawings, you construct the facility, and a key becomes the procedures you develop. These are procedures that your people will be trained on. Training is a key component of running a nuclear facility and remaining compliant. and a lot of training into the procedures. You perform your operational readiness review, all the steps that you go through prior to first introducing uranium into your system, and then second, validating that you are indeed, you have built a facility, all of the commitments you've made to your regulator are in place, and you're prepared to begin your operation. I mentioned a key cornerstone being the integrated safety analysis. And the inputs include the facility and process descriptions, your organization, and those become an input, and then another input becomes what are the programs and plans that you have put in place at your facility. You have a radiation protection program. You've created a nuclear criticality safety organization, fire departments, fire safety, emergency management. These are all systems and organizations that you have put into place as part of your operational plans for your facility. This is the design of your facility and all of your process descriptions. Out of this comes your environmental safety report, or environmental report. You go in, you do this in-depth analysis. You've got this design. What if this valve fails? What results? Well, if that valve fails, or the temperature goes high, now I could overheat a cylinder, and so you start to look at what are the things that can go wrong. And, for example, what's the probability of that happening? And a number is established, and maybe it's 10 to the minus 3. Okay, well, the goal is to get to where the probability is 10 to the minus 6. So you say, well, what if I make redundant instrumentation? And the design, okay, we're going to give you a credit for a -1, so you're now at 10 to the minus 4. Okay, well, I'm going to have people do check a reading or something, so you put in an administrative control and you get a little more credit. You say, well, if it started overheating, the fire department can be here. And so you start looking through what are all the things I need to do in order to bring the probability to 10 to the minus 6. Now, I'm giving you the example of the one that I went through when we did the lead cascade for the American Centrifuge Program. But you go through and you do a very detailed analysis of all the potential, all that you can identify, potential safety situations. You identify, here's an unreviewed safety question. When you're done, it's a reviewed safety question. And out of that, you establish the things you have to do to ensure that would never happen. Okay? And items that you identify that have to be done, or design items, become items relied on for safety, or today we call them IROS. For those of us who have been in the industry a lot of years, for many years, they called those the technical safety requirements. That becomes instrumentation, and that can become something that somebody has to do on a routine basis. You will check this every 2 hours. And the 2 hours comes from a timely analysis of how could the answer or the accident occur. Ray alluded to offenses there. So from a vulnerability, that's like the first line of defense. The next is the camera takes a picture. Okay, so you cut the fence, that didn't get it, but somebody knew the fence was cut, the camera was out of service, and you kind of work your way through, and I can guarantee that the people that worked at Y12 and familiar with this just kind of viewed this as, you know, the Bermuda Triangle event, if you could. How could all these things go wrong simultaneously? And that's what you do with your integrated safety analysis. And when you identify these items, they now become placed under your special quality assurance and control program to make sure they always work. Yes?
You know, just one comment, I mean, for the folks that are here, especially at our universities, of why you really need to have a system like this, because part of the failure at Y12 is, you know, we hear a lot now about, you know, security by design. Well, I'll tell you, the highly enriched uranium manufacturing facility is designed as a denial facility that, you know, is going to protect that material. There was never a threat to material by the none that was coming in. But because of that dependency on that denial strategy, that security by design, it allowed for these waivers such as that camera to not be fixed immediately, for some of the activities associated with the guard's reactions of the nuisance alarm, because they knew that nobody was going to get to that facility. Which, what they didn't put into that analysis is what happens when just penetrating the fence can do in shutting down of the overall facility and the overall dramatic effect. Just like a terrorist out here that wants to set off a dirty bomb. Is the dirty bomb going to kill a lot of people? No. It's the impact that it causes is the same thing that happened that you saw at Watch Well. Just as a point of why you need to go through each of these measures.
Yeah, and that's the same thing we have in some of our accident scenarios. Do you ever get close to an accident? No. But you have taken credit for barriers, and the publicity many times is the damage. Yes?
I was wondering, there was talk of change in contractor. This seemed to have been kind of a breakdown in security culture. That's something we talked a lot about at the University of Georgia, about studies the issues of security culture and the challenges of building a security culture. And I didn't know if DOE implemented new regulations and is scrutinizing more closely the new contractor that's taken over security at Y12, and what kinds of oversight is in place to kind of test security culture. Because in the first case, when the fence was cut, there was, oh, it's just a false alarm, we're not going to look at it. Kind of a classic case of security culture failure.
I'm going to let Morris address the specific Y12 question, and I want to, since the title of this is Culture of Compliance, I want to address the culture question. Morris?
Yeah, I mean, one of the things that's been looked at is, you know, you can point at a contractor, yeah, the contractor Wackenhut was fired, as well as all the senior management associated with the M&O contractor was fired. However, you also need to understand that for those cameras to be out, those waivers had to be signed off by the Department of Energy. Okay, so there was a whole system approach to this. It's not just a contractor failing to do their job. It's not just, it was really the whole upper level of this non-compliance, thinking that there was no issue there, no problem signing off on a waiver because we have this security issue. The issue about not, you know, the nuisance alarms, the ironic part is we train other countries of how not to be distracted and not to avoid nuisance alarms. Well, they were having hundreds of nuisance alarms going off in a 24-hour period. So we put those operators in an environment that you couldn't expect them to not become somewhat complacent or accustomed to that. And so they worked on that. They put in a whole new systems that you don't have. All those nuisance alarms, as well as hit at the culture associated with that. So they've really tried to look into root causes that can put you in that environment to try to overcome those things.
I've titled this The Culture of Compliance. And as a plant manager, you'll settle for compliance. But what you really want is a culture of commitment, that you have really bought in that this is important. And transitioning from how, you know, people aren't really running around saying, why don't we change something? Most people really resist change. The Japanese say, change is management of pain. Okay? And so you've done it this way for a long time, and you come along and you were there, I'm sure, in the 90s for conduct of ops, Tiger teams, Defense Nuclear Safety Board. There was a lot of change in our lives, wasn't there? And some people bought it up and really got committed. You know, this stuff really makes sense. This is good stuff. This is what we should be doing. Then there's the, we've never done it this way before because that's human nature. And you can live with that as long as they'll become compliant. And the nuisance alarm. And it's just, to be compliant and committed, you have to implement every single piece of the program. Because I don't care who you are, if you get a nuisance alarm long enough, you're going to eventually, because you're human, ignore it. Hold that thought and let's see if we hit it in the summer. And when I say that I would have shot him, that's because my name's in the NRC compliance license as a guy that goes to jail. You know, so that gives me a vested interest. But the challenge is, your challenge is technical, getting your degree. The challenge in keeping nuclear power and nuclear missions as an option in the future is to be able to make the kind of commitments required in the nuclear world. So we go through a lot of analysis, and that doesn't mean you got everything perfect the first time. So you might be working on something and you'll say, is this something we've reviewed, or do I have an unreviewed safety question? Which you've got programs in place to make sure that if you do, those get addressed. Let me tell you this too. I had plenty of employees the manager at Y12 would have shot. I'm not telling you we didn't have issues. We didn't have issues, but you're trying to change the culture of 4,000 employees. You know, you're trying to create this culture, and lots of challenges. One of the best practices that we came up with was, again, we're getting the first Part 70 license. We've got this very detailed analysis of all the safety, regulatory safety type things. And we've got to make sure that we get those to the floor, to where people are properly trained, to where those commitments are in the procedure somewhere. In other words, I was curious, with your camera issue, were you in some kind of limited condition operation?
Well, I mean, a lot of times you get the waivers that you've got 90 days to fix, or those kind of things. It's inside an approved window.
It's in an approved window, right.
And that there was another camera that, you know, was supposed to pick it up. Well, of course it did, but it was so fuzzy that the guard didn't see them cutting in the fence in the lower left-hand corner.
Yeah.
Okay, so.
Yeah, so the issue here, people were aware of one day everybody said, we're going to ignore all this. But so what we wanted to make sure is every commitment we made, that we could track that in some manner to prove that we have the mechanism in place to implement this at the floor. So what we did, we made a listing of all of our commitments. And for example, we said, we're going to sample an NDA and every cylinder that comes in, and we're going to weigh it, and X number of those cylinders we're going to pull a sample from, and we're going to do some destructive assay analysis, and we're going to have a program that validates that our program is working, that the NDA measurement we're taking in order to credit the material coming in is good enough. So what you do, you assign the commitment to a lead organization. And the organization addresses the commitment not only in their license, but also, or in their organization, but they also say, okay, in order to honor this commitment, I have to also make sure, in order to comply, I have to make sure that all of the other effective organizations are notified and do their part also, and that they address their commitment in their procedure and all their training. So the example I use is the Material Control and Accountability Group have a commitment that they're going to perform we as a company are going to perform destructive assay analysis on a certain percentage of the cylinders we receive. And how they do that is then it will flow into the operations group, it'll flow into the maintenance group. So when it comes in, somebody says, okay, my procedure says I'm going to sample X number, and that group determines, they tell the laboratory I'm going to sample X number, so they have in their procedure. And marked in their procedure, we used a little denotation to show this is an NRC. We actually came up with a little caricature that said IFOR, IROF, IROF, so that when people were performing that step, they knew that step was tied to a regulatory requirement. So we did that with our mapping document, that they realized this is a more than just a routine operation. It's tied to our commitment to the NRC, who is our regulator. Okay, you've designed this facility, you've analyzed this facility based on a fixed design. Once the facility is built and started up, you go back and you as-built your drawing so that it reflects exactly what's installed in the field. And we use a configuration control board in order to oversee configuration management, which is defined as the process for maintaining functional and physical performance attributes with the design and operational requirements throughout product system life for the life cycle of the whole plant. So what that means is we have a board that ensures that any changes to the baseline design are done in such a way that they preserve compliance with safety, security, safeguards, and mission requirements. When your engineering people do a design change before it's implemented in the field, a board comprised of subject matter experts from the design engineering, the systems engineering, safety engineering, and the affected organ securities in here, they review it to see that this change in no way compromises any of the system for which we've either taken credit or that has an impact on ensuring that we maintain our safety envelope. So configuration control board of the plant is typically chaired by the engineering organization at our facility, because the engineering organization owns the plant design. We also have what we call a plant operations review committee. Sometimes these are called a site operations review committee, but actually at most DOE or NRC regulated facilities, they are called a PORC. And this is a group that advises the plant manager on all matters related to nuclear safety. And the members of this are regulatory affairs, criticality safety, operations, maintenance, engineering. So it's the group that looks at procedures and practices and things done different maybe than it's different than maintaining the configuration control of the plant. But if somebody comes through and wants to make a change to a procedure or something you're doing from an operating perspective, this group ensures that they review all the procedures. They review any safety evaluations. Remember, there's an initial safety evaluation done. If you do a change or modification, someone does a review of the evaluations, especially if we determine, you know, this really represents an unreviewed safety question. This is something that really wasn't completely analyzed when we did the original analysis of our plant. They They review any changes to these items relied on for safety or anything to the operating license, because you have to go to the NRC to request those. Now, there is a mechanism to request some kind of an interperiod mode you're allowed to operate while you get your approval back from the NRC. I never experienced one of those, but I know it was there. And anytime there's a violation of an item relied on for safety, this particular committee is involved in looking into that. And one of the reasons you want your higher level committee and making sure you look at the detail is what Morris referred to as looking, what's the root cause of this? Many times, a quick look might give you a superficial, but when you get into it and you start pulling the string and looking at what really caused, and many times it's an accumulation of conditions like Morris mentioned there. In my experience, I would say 80% of the issues that we had involved something in some way, shape, or form with a communication breakdown. And that can be communication as in maybe there was a problem with the training. It can be communication with writing the work instructions for a shift. It could be a communication as maybe some confusion over the roles and responsibilities. And part of what that leads me to share are two things. At least 90% of your people want to do a good job. And when you get to a nuclear facility, maybe it's higher. Because when you look at the requirements that we place on just the selection process of whom you're even going to interview, you look at the requirements of the people. You know, these are not people that have been, you know, working selling cars or working doing something that wasn't technical or wasn't rigorous. And so you're going through a screening process, and then you're spending a lot of time training and developing these people. And hopefully you've created an environment where the people really buy in and there's a lot of commitment. So what we used to typically see as a challenge was, are the systems themselves properly structured, or do we have a problem within the system? That being kind of the compliance it starts from the pre-conceptual. You start looking at what are my compliance requirements. And you, as a uranium enrichment facility, you're there to enrich, you're there to run the plant safely. You got a regulator that only cares about running the plant safely. The NRC has one mission. And you also have you have a senior board and stakeholders, and you're there to make money. Do not get me wrong. But you want to lose money? Get crossways with one of your compliance and shut down and don't run a withdrawal facility for 8 days. And that's a really quick way to lose maybe $8 million. So compliance is important, because the reality is when you set up a design like we did ours from the beginning, and you have the capability to analyze and implement your regulatory requirements in the most effective, efficient way, they're built in just the same as you build in the technical pieces of that required to economically enrich uranium. It's the most key point. If you're not running, you're not making money. Data shows with the operation of nuclear power plants, the power plants operated in the United States that have the best safety and compliance records with the NRC also are the most productive and the most profitable. And I liken a part of that to, one thing is they don't get themselves in regulatory issues that affect them from the standpoint of even being able to operate. And two, I think they've been successful in being able to transition the workforce to the proper compliance culture environment that leads to success in the nuclear industry. You need a questioning attitude in the workplace. That is, you don't walk by and you see something and say, that might not be right. Well, I'll think about it later. You mention it to somebody. You have this questioning attitude. From the perspective of management, you provide training and reinforcement to the workforce. Morris and I were having a discussion earlier about the different cultures we see in different environments as far as the amount of training and employee development put into people from different organizations. Distinguish the highly significant from the less significant. You've got a questioning attitude, but you have to ensure that you're not identifying or capturing so many insignificant that you lose sight of what's significant, and you have to be able to prioritize at what rate or in what order do things need to be fixed. Because you've got a limited amount of manpower. Make sure you're working on your high priority activity. Root cause analysis training. What's the root cause? Where's the breakdown? I've had the experience the root cause was we let nuisance alarms go too long. We should have prioritized it. The alarms by themselves weren't a big thing. And I've had the experience that the person ignored the alarm because your assumption is it's been a false alarm for the last 20. Timely implementation of these corrective actions to fix things. I talked about motivating a workforce. I talked about creating a culture. I talked about wanting compliance. But if we as management don't fix these problems, then the workforce starts to believe, wait a minute, you're not walking the talk. I thought this was important. People see better than they hear. I can send them lots of fancy safety analysis or announcements with pretty pictures. I can go out once a month, eat lunch with them, and talk with them. But if every day they walk by that pump that's supposed to be so important and it's still tagged out, and wait, you said it was important. After a while, it's human nature to thought we were all in this together. Lessons learned across organizations. I may have, and we do this in several ways, but we used to have our lessons learned of issues come, and they wouldn't necessarily be at my plant. Somebody's having a problem in a certain area. They share that with our regulatory people, and we say, where could this affect us here? In other words, share the lesson learned not only within your plant, but across plants, because you don't want to necessarily have to wait to learn and implement them one at a time. Reinforce and communicate. I call it walking the talk, and it's walking the talk from management. One of the programs that we implement at nuclear facilities, a program we call management by walking around. At my facility, it meant the senior manager spent a minimum of 4 hours a week and hopefully 8 hours a week out in their spaces listening to the problems firsthand. It does a number of things. One, it helps the management understand better what is done on the floor and what happens at the plant. Two, obviously it offers a mechanism for communication and better understanding. And three, it demonstrates to the workforce that the management is committed to compliance also. So this becomes a very important piece. Now the bad news is, you're shooting for perfection and you never get there. I liken this to the yearly safety meetings. We get up and give the safety awards, and before you can even start feeling good, we announce next year's goals, which look even harder to reach. And it's a piece of the nuclear safety culture. You're just always pursuing. How can I do things even better? I can say this from my experience that. A couple times, maybe twice in my whole career, I felt like I was members of a team that for some period of time had real synergy. That rules out Tennessee basketball team, doesn't it? Okay. That'd be Florida, maybe.
Right.
But synergy is in, if I had something to do, one of my senior managers might say, that has to be done, and Jim's really busy right now. I'm gonna call Jim and say, I'm gonna run this down for you. But it's that point, you build a lot of effort into this integrated safety analysis. You've done a lot of training and skill development. So as a team, you know all of the things that need to be done to get things, to make sure you're successful. And actually what that means is the people look and say, Jim owns that problem, but I can help Jim with that problem. And so in that regard, the operation of a nuclear facility is a unique challenge. And when I look back, and I love the Manhattan Project, and when I look back, I think some of the reasons that the early Manhattan Project, and then in my case, we were actually the Atoms for Peace when they started building for peaceful uses. I think one of the reasons some of those things were successful is that our country had just come through it went through a Great Depression. It went through a tremendous war. Where I live, we went through the worst flood in history, and you're at war, and the people were working together for a common mission. And as Ray alluded to, lots of people worked hard all day long, but weren't quite really sure what they were doing. But they knew it was important to our ability to hopefully win a war. And so the operation of a nuclear facility requires that everybody does their job. It requires that everybody complies, and if we're really fortunate, it requires that everybody buys in and is committed. So with that, I'll open it up for any questions. Yes, sir. Yes, sir.
Does the,
Let's get the mic. Let's get the mics out if you can, because
Okay, we can do
we
that.
can't hear you if.
Thank you. Does the modification to or evaluation of or non-compliance to an IROC require a reevaluation of the ISA?
It can. Here's what you do. When you go to look at it and you start to look at the IROC, you determine, do I have an unreviewed safety question? Is there a piece of this that I missed when I did that's where the term unreviewed safety question. So it potentially could. Potentially. Let me tell you what we did one time. If you've heard the term verbatim compliance, that means that whatever you've written down, verbatim is how you're going to comply. We had a requirement that we had submitted that was written wrong. And it was approved. And it said that, I'll get it backwards, but you'll have pressure, you'll have the first indication will be a pressure alarm, and then you will have redundant temperature alarms. And it was written wrong. Rather than have to take the time to rewrite and change it, we rewired, did the system, put it in compliance until we had time to get the proper approval. That was the $8 million one I told you about. But that's where and I think that explains it more, that's where you enter your unreviewed safety question. Wait, here's a problem here. Did we adequately analyze it before? Good question.
Can I get your perspective from an operations management of the interface between safety and security, and kind of how you would reconcile a culture of compliance between the two of those?
Okay? It's not an accident that the safety and security organizations do not report to the operations manager. Okay, so one of the things that you want in your organization is you want a certain amount of self-independence, that they're part of another organization. That's one thing. As an operations manager, you're not going to hear a lot of operations managers say that, but you will today, the old guys. So it's important that they have a separate, independent, if you will, piece. Now, and Morris, I really would like for you to speak to this one, because you mentioned security by design, and I've done a lot of work on safeguards by design for Michael. One of the problems that we've encountered in the past is we do the design and then we put the security piece in. And because they weren't involved up front, maybe, we don't build as much into it that we could. And so we end up kind of laying this layer of security design on top of the process design. And there's no such thing as zero risk. So you could maybe get to that you have zero security risk, and the reason is you're not producing any products, so you're really safe. So it's got to be independent, because otherwise you've got an individual that is in a position on their own to maybe compromise security in the name of production. So the sooner that you get the groups working together, the more effectively you can design a system that accomplishes both missions. Let him speak to that, being a Y12, and that's more than a great question. That becomes one of the keys of life.
Yeah, I mean, what you'll see, and Jim alluded to that. I mean, the interface between safety and security is a lot of the same core concepts of compliance and culture that you'll have with a safe operation are the same things that will lead over to a secure operation. And it's, there's a reason why you see the same circle being used for integrated safety management as you do for integrated security management. It all fits in that same sector, in the same practices, because if you see a facility that is safe, that facility is most likely also going to be secure.
Yes.
And the same thing, I like the point that he made associated with, you have to have operations figured into that overall circle. Because that used to be my complaint as a program manager a lot of times is, yeah, we were perfectly safe and perfectly secure, but it's because they didn't produce any product.
Yeah.
Okay, and so then it gets back to, well, why are we here? So, I mean, if you're not producing product, you're not operating, you have to have all of those integrated together, proper interfaces with not one dictating over the other. They all have to be in sync. So there's a very, very good interface that you have to have between all of those.
I think the other thing I'd add that Morris kind of reminded me, in just the words he selected, the security and the ops people, they need to have some understanding of why the other people do what they do too. If your operator's out there and he realizes I'm doing this because it provides me this security enhancement or safeguards or safety enhancement, then they realize to not do it might compromise all of our jobs, because an accident anywhere is an accident everywhere. But I went through that one in the early 90s, security, and that was it. One of the Tiger teams decided, we came in, we looked at security. And being an ops at the time, I said, I'm really struggling with this, because we're going to be really safe. A lot of stuff's going to go in that building, but nothing's going to come out. Well, about 6 months later, they said, we're really behind on changing seals. Why is that? The seals are all in that building where I told you they weren't going to get out. So now we're not making much money, and it becomes, we're not making as much money. Maybe we ought to look at this. So, it was pain, took a little while, but you cannot minimize the understanding of the value of integrating these groups from the time they meet in the preconceptual stage. And they're developing some appreciation of what the others do helps. Okay, good.
Jim, I'm gonna put you on the spot a little bit.
Again? Okay, good.
Seeing the evolution of compliance from back in the Cold War, early or mid-Cold War years till now, I think we've lost a little something, our ability to field test new approaches, new technologies that in facilities today. It's almost become cost prohibitive. And we talk about technology of falling into a valley of death because we can't get the resources to do these field tests. Do you have any thoughts or ideas on that?
I got a couple. One is there actually is quite a bit of stuff in the NRC that you can look at to increase your flexibility to be able to perform tests that provide you some flexibility of being able to adjust like set points and things you want to do to get your data. You can bound what you're going to allow yourself to do. So there's a mechanism to be looked at and evaluated. And I know exactly where you're coming from. Now I can tell you the other story. One time we as-built an autoclave. An autoclave is to heat the cylinder and turn it to a liquid and feed it to a cascade, and it's your worst accident. It's your base. There's a term for it. Accident of concern, because you got a 14-ton cylinder. If it ruptures and it's liquid, you can have off-site consequences. So these were really important. And so we went out and we found, okay, here's the switch to open this. What's these other wires? Wait a minute, here's the switch to open it from the supervisor's office. What's this other wire? Well, here the guy could open it from the lunchroom. I mean, here's some other switches, and they were put on by the night shift, you can bet on that, just for convenience. Well, we drifted a long way from configuration control. So, but there's a way to write testing plans, but you got to really define where you want to be. The other thing I will add is the USEC. I had the same fear. I started USEC centrifuge program in late '99. I had the same fear. How am I going to do a cascade where I'm going to want to every day be changing set points and doing different things because I'm building this cascade and I've got a model. But it's not necessarily the model for this machine, and this model hadn't been run since '85, and really the first thing I got to do is I got to prove the model's still good. So I really worried about that. In fact, I was driving home from Oak Ridge when it hit me. What's the thing that scares me to death? I'm not worried about a release. I only had a couple 100 kilograms of material in a subatmospheric system. I don't have off-site consequences. My biggest concern was nuclear criticality safety. So I got back to the plant. I called, you may know Ed Wagner, I called my NCS guy, and I said, I want to design a system and I want to run tests, and I want to make sure that I don't even have to worry about nuclear criticality safety. He comes back and he says, if you keep it under 250 kilograms for your total inventory, there's no way you could have a criticality accident. So that became one of the design parameters for the lead cascade. It also became one of my primary TSRs. In other words, I won't be dragging any of your extra stuff and dumping it in Jim's house, because Jim's only allowed to have 250 kilograms. But it became a key administrative piece. But what it meant was, I just cranked that baby up and down. Now, I still had to worry that I didn't go past my 10%. But remember, I was only producing 5. That was my target. So my other buffer was, I said, let's get a license for 10%. Let's give ourselves some operating range. Because a 24-inch cylinder represents an unsafe geometry, but not if you don't have enough material. But I could still have too much assay, just violate that. and I'll never withdraw it. I'll run it on recycle, I'll never withdraw it. So when I withdraw it, I'll mix this back together and I got 0.711. That's sheer luck. But wasn't completely luck, but I had the same concern Chris did. How am I going to do experiments in this tightly controlled world? And I said, hey, tell me how I can avoid, because I can guarantee you in an enrichment facility that has 42-inch pipes and at one time produced 97% material, and even when I was there we were producing 495, and shipping, NCS is a real issue. But we are able to do that particular one that way. And there is a mechanism for testing, and you're only allowed to do it a certain number of days. You fill it out, you do the reviews. But I didn't say it was easy. I just said it's a challenge. And there's a mechanism. But that's a good question.
All
It's
right.
one that makes retirement look a lot better.
All right, well, we are at the time for our break.
Good.
We're actually a few minutes behind, so let's take a 15-minute break. There's plenty of food and drink out here in the rotunda. So please be back in here at 11:10. All right?
Thank you.
Thank you very much.